All right, so this is the second part of reviewing for test 3, and we're on number 15. Is that right? 15? Okay, so on 15, it gives us a function and asks us to find all of the possible rational zeros. Okay, so the function on this one is 14x to the 6th minus 20x to the 3rd plus 6x squared minus 9x plus 5. So remember, if you are finding all of the possible rational zeros, the first thing you're going to do is look at the last term and find the factors of it. So this is a good one because there's only one way to multiply to get 5, right? 5 times 1. Then you look at the coefficient of the leading term, which in this case is 14, and make another column with the factors of 14. So how do you multiply to get 14? 14 and 1, and 7 and 2. Then you are going to make fractions with the 5 being the numerator over all of those, using positive and negative, which would be positive and negative 5/14, positive and negative 5/7, positive and negative 5/2, and positive negative 5/1, which is just 5. Then you're going to start all over using the 1 as your numerator. So positive and negative 1/14, positive and negative 1/7, positive and negative 1/2, and positive and negative 1. Okay, and this one is multiple choice, so you're not going to have to type all that out, right? So that's what it is on number 15. Number 16. Number 16 is going to give us a function and ask us to find its rational zero and any other zeros. So let's see. F of x equals 2x cubed plus 3x squared plus 18x plus 27. So a lot of times if you can factor your function, then once you factor it and get your factors, you can set those equal to 0 to find the zeros. So I'm going to try to factor this one. Since it's not squared, it's cubed. There's nothing in common with all 4 terms, which means what should I do? Put the 4 terms in groups of 2. So if I group the first 2, group the second 2, what's in common in the first group? X squared. If I take the x squared out of this first term, I'll be left with 2x plus, if I take the x squared out of the second term, all I'm left with is that 3. And then pull the greatest common factor out of the second group. What is the biggest number that goes into 18 and 27? 9, good. And I don't need to change signs, right? These are both positive, and I want them to stay positive. So I don't need to change signs. I'm pulling out, I don't need to pull out a negative to change signs. So I'm pulling out a positive 9, which again leaves me with 2x plus 3. And remember, if you're factoring by grouping, these two have to be the same thing, because what's the next step? To pull out that 2x plus 3, because now it's the common factor. And what's left over after you pull out the 2x plus 3? That's right, x squared plus 9. So this one's done. So it's going to make a 0, right? That's a factor. If I set it equal to 0 and solve it for x, I'll subtract 3 from both sides. So 2x equals -3 and divide by 2. So x equals -3/2. So there is a rational 0. My other zeros are coming from this factor. Now, it's x squared, which means where can I find its zeros? It's not a difference of squares because this is a plus and not a minus, right? If it was a minus, I would do x plus 3x minus 3. But it's an x squared plus 9. So I can just put that in quad to find its zeros. So if I put it in quad, my A would be 1. What's going to be my B? 0, right? There's not an x, so there is no coefficient of x. So it's a 0. 9 is C. So if I put that in quad, what's it going to give you? Didn't we do that on Wednesday? I think we did that.
Well, we put the 1 on there, but all the rest of
Oh.
them.
If you put that in for A, B, and C, what does that give you? Plus and minus 3i. So those are your other zeros. 3i and -3i. So that's your rational one. That's your other one. The second part of this question wants you to write out what would be the factorization. So taking it back to their factors, what factor did -3/2 come from? 2x plus 3. What about these? What would this one have come from? X minus 3i and x plus 3i. So rational 0.
So we're going back.
Other zeros. And this is the B part of that question, the factorization. 17. Find the domain. So now we're getting into the rational function where the x's, they have x's in their denominator. All right, so when you have a rational function, you want to leave out the zeros of the denominator of your domain, right? So since it is quad, I can take it straight to quad. This is not a bad factoring problem though. X and x for x squared. Factors of 7 that add to 8 would be +7 and +1. So if those are the factors, what would this end up being? It's 0. 7, -1. So the first part of this one wants you to write it as x can't equal what? And then after that, we're going to write it in interval notation. So what can x not equal? Good. And below that, it says it wants you to write your answers in ascending order, which means on the number line, this is how it would come, right? You're going to come up to -7 first and then -1. So it wants you to write x can't equal -7 first. A lot of people miss that problem because they put the -1 first and then the -7. Then the interval, and now that you have this number line, what is the first interval? Good. negative infinity to -7 in union with this middle interval. So -7 to -1. And then the last interval would be -1 to positive infinity. Number 18. It's another domain problem. It's just going to want this kind of answer though, the interval notation. F of x equals -2 over x squared minus 2x minus 35. In interval notation, so again, it's quad, so you can find your zeros in quad. So A is 1, B is -2, C is -35. So what are your zeros? 7 and -5. So we need to write the domain in interval notation. So you're going to come up to -5 first and then 7. So your first interval is negative infinity to -5 in union with this middle interval, which is -5 to 7, in union with 7 to infinity. All right, the next several problems are on that 8.5 where I gave you those notes because it talked about so many different characteristics of these rational functions. And we talked about vertical asymptotes, horizontal asymptotes, domain, x-intercepts, y-intercepts, all that. Okay, 8.5. Number 19 says, list all the asymptotes of the following function and then graph it. So we have 9 over x squared minus 4. So the first thing it wants to know are where are the vertical asymptotes? Remember what those are. Those are the zeros of the denominator that are not also zeros of the numerator. Okay, so this one, the zeros of the denominator, that's a difference of squares, so it's not too bad to factor that denominator. This one's 0 will be -2, and this one will be +2. There's not any zeros of the numerator because it doesn't have an x. So these are both vertical asymptotes. And remember, this one says type as an equation. It doesn't have the x equals there for you. So that means we have to write it in. So if my vertical asymptotes are at x equals -2 and x equals +2, and my scale is going by 2, so it just has 2 hash marks, and that one's 4, so that means they're going by 2. So let's see, there's one at -2, one at +2. There is no oblique asymptote. Remember, we didn't work problems that had oblique asymptotes. The last part says, where is the horizontal asymptote? Now, remember where that comes from. It comes from that chart that's comparing the degree of the numerator with the degree of the denominator. Good, because the degree of the numerator is 0. The degree of the denominator is 2. So if the top degree is less than the bottom degree, the horizontal asymptote is automatically y equals 0, which is here. Now, just knowing those things, it's actually only going to narrow it down to 2 options on the multiple choice. Okay, it's going to have B and D, well, on this sheet. There's going to be 2 of them that are going to have these vertical asymptotes. So even though it doesn't ask me to find another characteristic, I'm still going to have to. The easiest thing to find from the way it's given to me here is the y-intercept. Because remember, how do you find the y-intercept? You replace all the x's with zeros, which does what to your x terms? Just knocks them out. So where is it going to cross the y? Right. So it's going to cross the y-axis in the negative area. And the difference between the 2 that you have left that have these vertical asymptotes, one's going to have a positive y-intercept and the other one will have a negative. Number 20. Determine the vertical asymptotes of this function. So once again, remember the vertical asymptotes are zeros of the denominator that are not zeros of the numerator. So on this one, this time there is an x in your numerator. What number, when you plug it in here and cube it, is 0? 0, right? 0 cubed is 0. So that's your 0 of your numerator. All right, let's find the zeros of the denominator, up to 3. So let's see. I can pull out an x, which will leave me with 3x squared minus x minus 30, which means I can quad that, right? Because it's x squared. Your A, B, and C. 3, -1, -30. So that gives me what as the zeros for what's inside here? What about this one? What does it make? 0. So this factor made this 0. That's x squared. So we put it in a quad program to get the other 2. So my zeros of the denominator are 0, 10/3, and -3. Vertical asymptotes are zeros of your denominator as long as they're what? Not zeros of the numerator. So that one does not make a vertical asymptote. Your only vertical asymptotes are x equals 10/3 and -3. (21). All right. 21 just wants me to find the horizontal asymptote. Which means I need to compare the degree of the numerator with the degree of the denominator. What's the degree of the numerator? 2. The degree of the denominator is 4. So numerator less than denominator, which means your horizontal asymptote is what? Y equals 0. All right, the next 2 problems are asking all the questions: the domain, the vertical asymptote, horizontal asymptote, x-intercept, y-intercept. all that. So the first thing I'm going to do on these next two problems is find the zeros of the numerator and denominator, right? Because that's going to answer a lot of the questions for me. Okay, so the function is f of x equals x squared plus 2x minus 15 over x squared plus 8x plus 15. So to find the zeros in the numerator and the denominator, I can just do quad on both of those. If I didn't have quad and factored, let's see, x and x for x squared, the factors of negative 15 that add to positive 2 would be a positive 5 and negative 3. If I factor down here, again, x and x for x squared, this time factors of 15 that add to 8. Positive 5, positive 3. So let's see what my zeros are. This one would be negative 5. This one will be positive 3. This one will be negative 5. And this one will be negative 3.
So if they're not 0, but they're still in both the numerator and the denominator.
The domain will take into account both of them. But when we start with the vertical asymptotes, those are zeros of the denominator that are not zeros of the numerator. So this one won't be a vertical asymptote. When we're talking about x-intercepts, those are the zeros of the numerator that are not zeros of the denominator. So this one won't be an x-intercept. Okay, and that's why I put all that on that notes sheet for 8.5. So you can just refer back to it. It's hard to remember all that. All right, the domain in interval notation. Where does the domain start? Negative infinity until it gets to negative 5. In union with what would be the middle interval? Right, negative 5 to negative 3. And what will be the other interval? Negative 3 to infinity. Mm-hmm. Yeah, because it's a rational function, which means that's a fancy way to say fraction. So you just don't want the denominator to equal 0 because that's undefined. So that's why you're only concerned with the denominator. The numerator can be anything. That's why you don't care about it in the domain. X-intercepts, Y-intercepts. X-intercepts are zeros of the numerator that are not zeros of the denominator, which means negative 5 doesn't x-intercept, only 3 does. Remember, when you're typing it in, what is an intercept? It's a point. It's a point where it crosses the x-axis. So remember, you would need to type it in as an ordered pair. So it's going to cross at 3, 0. Always, when you're typing in an answer and you see something underneath the answer blank, it's usually telling you how it wants the answer. It'll say, type it, make sure you type an ordered pair. Oh, no, it didn't. Oh, yeah, type an ordered pair. Yeah. Y-intercept. How do you find the y-intercept? Remember, the y-intercept is where the x coordinate is 0. So I have to think of all these x's being zeros. What happens to the terms that have x's if you replace them with zeros? Just knocks them out, right? So what are you left with? Negative 15 over positive 15, which is what? Negative 1. So negative 1 is the y-intercept, which means negative 1 goes in the y, 0's in the x. And then it wants your vertical and horizontal asymptotes. Vertical asymptotes, zeros of the denominator that are not zeros of the numerator. So the -5s don't count. X equals -3 is your only vertical asymptote. What about your horizontal? The degrees are equal, which means you use the leading coefficients to find your horizontal asymptote. What are both of these? So where is your horizontal asymptote? Y equals 1. There is no oblique. So let's sketch out what we know. Let's see, what's the scale here? The scale is going by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. -10. So I always do vertical asymptotes first, especially since it's multiple choice. I'm hoping that that's going to narrow it down. There's only one vertical asymptote at x equals -3. If these are going by 2s, there's -3, which actually does narrow it down. There's only 2 graphs that will have that. So I'm going to go now to my horizontal, which is at y equals 1. Again, if these are going by 2s, here's my horizontal, which will actually narrow that all the way down for you. The ones that have this vertical asymptote at -3, one of them will have the horizontal at +1. The other one will have it down in the negative, so you know it's not that. If that didn't narrow it all the way down, then you could go to intercepts. It's crossing the x at +3, and it's crossing the y at -1. 23. It's another one that asks all the questions. This time the function is f of x equals x squared plus 5x over 2x cubed minus 9x squared minus 5x. All right, I'm going to find the zeros of the numerator and denominator first. Okay, the numerator I could put in quad, or I could factor. I just need to pull out an x. That's all I can do to factor that, is pull out its greatest common factor of x, which leaves me with x plus 5. So what's this one 0 going to be? Yeah, and what about this one? So there's the zeros of the numerator. What about the denominator? I can also pull out an x, which leaves me with what? 2x squared minus 9x minus 5. So what's this one 0 going to be? 0. How can I find the other two? Quad. Okay, so 5, -1/2. All right, the domain. This domain question is actually multiple choice, and it's not interval notation. It's x is a real number, and x cannot equal blank, blank, and blank. What can x not equal? 0, 5, or -1/2. vertical asymptotes, zeros of the denominator that are not zeros of the numerator. So this one doesn't make a vertical asymptote. These two do. So 5 and -1/2. So x equals 5, x equals -1/2. The horizontal. The degree of the numerator is 2. The degree of the denominator is 3. So numerator is less than denominator, which automatically means y equals 0. The intercepts, x-intercepts. Zeros of the numerator that are not zeros of the denominator. So again, this doesn't make an x-intercept. Your only one is at -5. And you type that as an ordered pair, -5, 0. The y-intercept. Look at your original function. What happens to that denominator if you replace all of its x's with zeros? The 0. You can't have 0 in your denominator, which means what is your y-intercept? There's not one. No, that'll be, I know what you're saying. No, it'll just say, you'll type that the B answer. There is no y-intercept. It'll be a multiple choice and you just say there's not one. So let's see. So vertical asymptotes, 5 and -1/2. So the scale of the x-axis is going by 2. So if I'm doing 5, it'll be here. -1/2. Horizontal asymptote, y equals 0. Now, this is the one where that doesn't help us at all. All 4 options have all of those vertical asymptotes. The one thing that is going to help narrow it down is this. There will be 2 options that will cross the y-axis. So it's not either one of those, but I'm still going to be left with 2 options that don't cross the y-axis, because when it gets to the y-axis, it makes a hole on the y-axis and then keeps going. So I need to find out where that hole is. The x-coordinate of that hole comes from the 0 that canceled out. So which 0 canceled out? That, or the factor that cancels, because it's like these cancel each other. What was the 0 of both of those? The y-coordinate of the hole is, if you go back, once you've canceled this out and replace the x's with what's left, which is x plus 5 over 2x squared minus 9x minus 5, if you replace all those x's with this x coordinate, that's going to give you the y coordinate of the hole. So what's left if I replace all these x's with zeros? Which is negative. That's where the hole is, at -1. So it'll come and there'll be a hole at 0, -1. All right, 24 and 25 are dealing with those inequalities. Talking about where it's above or below 0. And remember what 0 is. 0, we solved these graphically, and 0 is our x-axis. So 24, you have x minus 4. X plus 2 is less than 0. So the ones that that we worked on these were all quads. So they all made parabolas, right? If I FOIL this together, that would give me x squared, right? That's what makes it quad and a parabola. What I needed to know about these parabolas is where they cross the x-axis or where their zeros are. So where is this one 0? 4, this one's at -2. So +4 and -2. The other thing I need to know about the parabola is if it opens up or if it's upside down. If I FOIL this, is my x squared going to be positive or negative? It's going to be positive, right? Which means, how does this parabola open? Upward, like this. So what's the question asking me? Where is this parabola less than 0? Here's 0, so it's less than it on this interval right here. So where does it start being less than 0? -2, and it's less than 0 until it gets to +4. Last one. X squared plus 20 is less than 3x. So this one's not all nice and neat and factored for us like the last one was. So I'm either going to factor it or have to put it in quad. But before I do that, I need to have this side be 0. So I need to move the 3x to the other side. So now I've got x squared minus 3x plus 20 is less than 0. I can't factor that because if I tried, I would be stuck, right? There's no factors of 20 that add to -3. So I do have to use quad on this one. With A being 1, B -3, and C 20. When I do that, and I'm trying to find x-intercepts, it tells me my solutions are 3 plus and minus I squared is 71 over 2. Where are you going to put that on the x-axis? You're not, right? It's an I. It's not on a number line. It's not a real number, which means what about this parabola? It's a positive x squared, which means it opens upward. What happens if you open upward? How do you not cross the x-axis? Be above it, right? This is the one that you were talking about with the special symbol. Where are the x-intercepts? There's not any. That's when you use that null set symbol.